In this section, we're going to be solving systems of nonlinear equations. We're going to stick to two equations and two variables in this section, but what I want to point out is one or both of our equations will be nonlinear, meaning the exponents on the x and or the y's won't necessarily be 1. So there's a lot of different ways to solve these equations, these systems of equations, depending on what kind of setup you have. So I wanted to get a variety of different types here. So in this first system that we're solving, a really important thing to notice is that we have x squareds in both the top and the bottom equation, and we have y squareds in both the top and the bottom equation, and then constants. So we have like terms in both of these. So the method that I'm going to use to solve this is I'm going to use the elimination method. You can use substitution. If you have a graphing utility, you can even use graphing and find out where the intersection points are. But I want to use the elimination method here. So remember, when we do the elimination method, we want to multiply one or both of our equations by some number to make one of our variables add to 0. So if we had 2x squared minus 3y squared equals 6, and x squared plus 2y squared equals 17, and let's say that I decided to make the x's add to 0, I would do that by multiplying this bottom equation by -2. The top equation stays, so that would turn this into 2x squared minus 3y squared equals 6. And the bottom equation would become -2x squared minus 4y squared equals -34. So when I add these two equations together, the x squareds will cancel to 0. -3y squared and -4y squared makes a -7y squared. And 6 minus 34 is -28. This is terrific. Now I can solve for the y squareds by first dividing both sides by -7, which gives me y squared equals 4. So y is equal to plus or minus 2. Okay, I know you know we need to find the corresponding x's, so we have two different possibilities. We have y equals 2 and then y equals -2. So pick either equation. It doesn't matter whether you plug it into the top equation or the bottom equation. I'm going to choose the bottom equation just because it's easier numbers. X squared plus 2 times 2 squared equals 17 gives me x squared plus, let's see, 2 squared is 4 times 2 is 8. So x squared equals 9. So x is plus or minus 3. So this tells me I have x is 3 goes with y is 2, and x is -3 goes with y is 2. Okay, let's see what we get when we plug in y equals -2. So I'll plug it into the bottom equation again, just because the numbers are smaller. X squared plus 2 times -2 squared equals 17. But when we square -2, we get 4 again. So this is going to be x squared plus 8 again equals 17. X squared equals 9, so x equals plus or minus 3. So that means I have x equals 3 goes with y is -2, and x equals -3 goes with y is -2. Okay, so we have 4 different answers. What that means for this graph is we have 4 different points of intersection. And if you have graphed things recently, you might recognize this top equation, since the x's and y's are being subtracted, as a hyperbola, and the bottom equation, since the x's and y's are x squareds and y squareds are being added, as an ellipse. So what you have is a situation where both of those are centered at 0. You have a hyperbola intersecting with an ellipse. I'll try that ellipse a little bit more carefully. There we go. And it's intersecting in 4 different places. Apparently at x equals 3 and -3, and at y equals 2 and -2. Let's do another example. Now let's solve the system of equations x times y equals 4 and 2x squared plus y squared equals 18. Now what I want you to notice about this one is, unlike the previous example, we don't have like terms lining up. We don't have an x squared and a y squared lining up with the x and the y in the top equation. But we do have nonlinear. We have squareds on the x's and the y's, and anything that has x and y multiplied together would also be squared, would also be nonlinear, sorry. So I can't use the method of elimination like I did in the last one because we don't have those like terms. So in this section, I'm going to use the method of substitution. Okay, if you remember using substitution, you pick either equation that you want to and you isolate the easiest looking variable. So I'm going to pick the top equation because it looks easier to isolate an x or a y than the bottom equation. And I'm going to randomly choose to isolate the y. So that would be if xy equals 4, we would divide both sides by x. So we would have y equals 4 divided by x. Okay. After we isolate that variable, then we substitute or plug that result into our other equation. Okay, so we're going to take y equals 4 over x and we're going to plug it into 2x squared plus y squared equals 18. That'll give us 2x squared plus 4 over x all squared equals 18. Okay, squaring the 4 over x gives 2x squared plus 16 over x squared equals 18. Okay, now we're back to solving for x. We have fractions here, so the first thing that we need to do is we need to clear our fractions. So let's multiply everything we have by an x squared. Okay, and when we do that, we get 2x to the 4th. The 16x squared over the x squared cancels, so we just have 16 equals 18x squared. Okay, let's get all of our x's on one side, so that'll give us 2x squared minus, 2x to the 4th minus 18x squared, if we write this in standard form, plus 16 equals 0. Now this is really cool. This is a factorable equation. So obviously the first thing I'm going to do is factor out the common factor of a 2, leaving x to the 4th minus 9x squared plus 8. Okay, what we have here inside the parentheses is what we call quadratic in form. So the first exponent, it might not be quadratic because the x to the 4th is not a 2, so it's not quadratic, but the exponent, the leading exponent is double the middle exponent, and then there's a constant at the end. So this is quadratic in form, and we can factor it like we did quadratic equations. So we'll have x squared and x squared. The numbers that multiply to be the 8, but add or subtract to be -9, are -8 and -1. When we set these equal to 0, we obviously don't include the 2 because it doesn't have an x with it. But we have x squared minus 8 equals 0 and x squared minus 1 equals 0. So the first equation gives us, I need more room, x squared equals 8 gives us x equals plus or minus the square root of 8. And if we simplify that, that's plus or minus 2 root 2. The other equation, x squared equals 1, gives us just plus or minus 1. Okay, now just like in the last example, I'm going to take each one of these 4 x values and plug it into one of our equations to get the y values. The only problem is I don't have room here, so I'm going to need to erase what we've got on the other side. Okay, so now we have our 4 values for x, and we're going to plug them in to one of our equations to get the y. Now you might be thinking that the top equation, y equals xy equals 4 would be a good choice, and it is a good choice. If we plug them into the top equation, we'll end up with, let's take this one, plus or minus 1. 1y equals 4, so y equals 4 goes with x equals 1. So we'll have 1 and 4. And if we do x equals -1, -1y equals 4, so y equals -4. So we get -1, -4. Now notice we could have plugged those into the bottom equation, the 2x squared plus y squared equals 18. It would have been nice because we have x squared equals 1. We could plug that directly in here. I want you to watch what happens if we do that. So instead, if we did 2 times x squared, and x squared is 1, plus y squared equals 18, whoops. Then, so that's 2 plus y squared equals 18. Y squared is 16. We have y equals plus or minus 4, which is exactly the same y values that we got before. We just didn't know previously that the positive x went with the positive 4 and the negative x went with the negative 4. So it's a little bit easier to see if we plug them into the top equation. Okay, now that we know that though, when we go to x squared equals 8, or x equals plus or minus 2, and we can plug them into the bottom equation, I'm going to plug x squared equals 8 into the bottom equation. So 2 times 8 plus y squared equals 18, which is 16 plus y squared equals 18. Subtracting the 16, we get y squared equals 2, so y equals plus or minus the square root of 2. Now I can cut a little bit of a couple corners here because I already know that positive x's go with positive y's because they have to multiply to be positive 4, and negative x must go with a negative y to multiply to be a positive 4. So then I get the result. Positive 2 root 2 for x goes with positive root 2 for y, and negative 2 root 2 for x goes with negative root 2 for y. So my 4 answers are 1, 4, -1, -4, positive 2 root 2 and root 2, and negative 2 root 2 and root 2. Let's do one last example. Okay, the last example we're going to do is a quick one. This example, there's a bunch of different ways that we could do this example. You technically can't do strictly the elimination method, even though the negative x squared and the positive x squared would cancel. You don't have like terms, but if you left those terms separated as y plus negative y squared, it would be okay. I'd like to show an example of substitution again. So I'm going to use substitution one more time. And it looks like the y in the top equation is by far the easiest thing to isolate. So if we add this x squared to the other side, that will give us y equals x squared. Great. And then we can plug that in for either the x or the y, whichever one you want to. Let's plug the y equals x squared in for x squared. So instead of x squared, we'll have y minus y squared equals 9. And I'm not thrilled that the y squared is negative, so I'm going to move everything over to the right-hand side, leaving me y squared minus y minus 9 equals 0. Now, if it were factorable, it'd be a little bit easier to factor with a positive y squared. Alas, that is not factorable. So I'm going to use the quadratic formula to solve for the y's. So let's see, b would be -1, so negative 1 is 1. Plus or minus the square root, b squared would be -1 squared is +1. And I see I made a mistake, minus 4 times a times c. That is a +9 that we left over there, not a -9. So that'd be 4 times 1 times +9, all over 2 times 1. So y is equal to 1 plus or minus the square root, -36 over 2. Which is a problem. We have 1 plus or minus the square root of -35 all over 2, which is imaginary in this part. That's perfectly okay to have imaginary answers to things in math, but remember, these are all finding intersection points, so we have no intersection points. So depending on how your textbook writes it, technically no solution isn't correct, but no real number solution will be perfectly fine. Okay, even though this didn't ask us to graph, I would still like to show you what this looks like. So up here in a different color, I'm going to show you the pictures because you definitely know what y equals x squared looks like. That is simply a parabola opening up. And furthermore, you probably know x squared minus y squared equals 9. Maybe, maybe not, but that is a hyperbola opening to the left and the right, and the center is at 0. Oops, and I made a slight mistake. We're going to have to go out 3 spaces, 1, 2, 3 for the 9. So here's what our hyperbola would look like. So what we have is 2 graphs, the parabola and the hyperbola, that don't ever intersect each other, which is why we have imaginary answers. We have no real intersection points.